Hello, this is Jeremy from Math Bootcamps, and today in this video what I'm going to do is show you how to find the x-intercepts of three different types of functions. You know, the way you find an x-intercept stays the same, always. However, what can change is how it looks when you go to find it, and that all depends on the type of function you're working with. All right, let's make sure we're all on the same page. X-intercepts. That's where the graph crosses the x-axis. When the graph crosses the x-axis, it must be that y equals 0. You have, in other words, no height to that point. Another way we talk about this is sometimes the zeros of the function or the solutions when you set this equal to 0, which is essentially the same thing. So for this first one, all I have to do is let y equal 0. And so that means that 5x minus 4 equals 0, because this is now 0. And so this is just a nicer way of writing that, right? And then I solve for x. I say, okay, 5x equals 4. And so x must equal 4 over 5. So there's a couple of different ways people like to say this. You could say at the point 4/5, because it's an x, comma 0, is the point where we cross the x-axis. Or you could say we have an x-intercept at the point, or at x equals 4/5. Or you could say at this point. You know, there's so many different ways to say it. The best bet if you're taking a class is to make sure that you're being consistent with how your instructor would like to see it, because sometimes they want you to write it a certain way to know that you know how that way makes sense compared to another way that might not make sense. From now on, what I'll do is I'll just get the x equals part and assume, okay, you'll set that other part up. So here again, I'm finding x-intercepts, so I set this equal to 0. So x squared minus x plus 6 equals 0. Okay, and I say, well, it's quadratic, so I'm going to see if I can factor it. That's going to be my best bet most of the time. I look at the 6 and I say, okay, factors are 6 and 1. No way to turn those into a minus 1, right? Okay, minus 1 and minus 6. Nah, not going to happen either. 2 and 3, well, the problem is they have to have the same sign because it's positive 6. So this isn't going to work either. If factoring is not going to work, well, what am I going to have to do? I'm going to have to use the quadratic formula, I think, unless I want to do completing the square, which I don't. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now you see how I just busted that out without thinking? If you're taking algebra, you need to be able to do the same thing. This comes out anytime you're dealing with a quadratic that doesn't obviously factor in a nice way. All right, so let's see what we get. Negative b, that would be negative 1. So that'd be 1 plus or minus the square root. Okay, negative 1 squared for b squared is 1 minus 4 times a, which is 1. And then c, which is 6. Okay, and then divided by 2a, which is 2 times 1, so that's just 2. Uh-oh, so something bad's about to happen. I don't know if you see it yet, but let's see. We get 1 plus or minus the square root. Okay, negative 4 times 6 is negative 24. Add a 1, I got negative 23. See there, you know, this should freak you out. That's very scary. Why is that so scary? You can't take the square root of a negative. Well, okay. If you had enough algebra, you know you can, and it's actually I, right? But the x-axis, that's in the real number, so we can't use an imaginary number for this. So in other words, this doesn't have a real solution, so this has no real solutions. Oh my God, what do you do then? Well, that means it actually doesn't cross the x-axis. So what this means is this has no x-intercepts. That's why I did this example. I wanted you to see one of those. No x-intercepts. No x-intercepts. So that means this parabola is sitting off in space somewhere away from the x-axis in such a way that it never crosses it. And so that will happen sometimes. You can always check with your calculator to make sure that it makes sense and graph it. But again, if you don't get a solution to this, a real solution, then you don't have an x-intercept. Okay, let's look at this last function, rational function. So again, I set y equal to 0 and solve. So I say, okay, I'm going to say 0 equals x minus 1 over x plus 4. All right, and then you're stuck, right? You're like, what do I do now? Well, the only way a fraction can equal 0 is if the top equals 0. So it must be that x minus 1 equals 0. Therefore, x must equal 1. So in other words, we have an x-intercept at x equals 1 using what we talked about up here. Or I could say the point 1 comma 0 is where the x-intercept is located, or where we cross the x-axis. So again, it seems complicated here, but if you just remember that a fraction can only equal 0 if the numerator equals 0, and then go from there, you'll get your intercept. So again, these can always be checked on a graph. I would encourage you to do that as you're practicing, to check your answers all the time. Make sure you're not getting any bad habits. And so, okay, maybe in another video, and you should watch how to find the y-intercept, right? So it's kind of the same idea.